Hi, welcome to my channel. Today in this video, we are going to see the next inheritance strategy in JPA, which is single table strategy. In our last video, we saw mapping between parent and child using mapped superclass inheritance, which looks something like this. In this type of strategy, every child has its respective table definition in the database, but the parent class does not have any. JPA uses this mapped superclass to share attributes or variables that we have defined in this class. Since the parent class is an abstract class and it is not an entity, we cannot create its object, so we use child repository to perform database operations. This means we can't use polymorphic queries to fetch all child records using the object of parent class. If we have associations defined in the child entities like one-to-many, many-to-many, and so on, we should keep these associations within the child entities itself. Now come to today's topic, single table inheritance strategy, which is quite opposite from the mapped superclass. In single table strategy, the parent is now an entity and does have a respective table definition in the database. Moreover, every child has a set of attributes or fields from the same table and responsible to fetch and update the data of those fields. In the context of JPA, however, every child still will be treated as a type of entity that does not have a separate table definition in the database. Since we are talking about inheritance here, so defining attributes in parent class which are commonly associated with multiple children's data is the same approach that we took in case of mapped superclass. Like in this example, whenever we update or fetch records of inbox or any other child in the hierarchy, these 4 columns are commonly required. Now, you might think that why this column SMS folder is not defined in any of these entity classes. That is because this field will be managed by JPA itself. JPA will use this field's data as an identifier of a child. For example, in this case, JPA will store inbox in this field whenever we insert record using the object of inbox. Similarly, it will save sent when we insert record using the object of sent, and so on. But we need to tell JPA that which column is reserved for identifier, and for that we use discriminator column annotation. Here we tell JPA that which column it can use to store child identifier. If we do not specify the discriminator column, JPA will automatically create a field dtype in our table to store the identifier value. The main advantage of this strategy is that it allows polymorphic queries, and the performance of such query is comparatively faster than others because we are storing all data in a single table and no joining required to fetch records. You can query parent to fetch records from all children. Like here in this example, we can query all records from SMS entity and the Hibernate will generate this SQL query. And similarly, you can query individual child for specific set of data. Like here in this example, we are querying all records from the inbox, and in response, Hibernate has generated this query putting the discriminator column SMS folder in where condition. So let's see this strategy in action. For this example, I created this SMS table, and here these 3 columns of this table belongs to different types of messages. For example, this field SMS type will receive data only when the record is inserted using the object of inbox entity. Similarly, this field delivered on will be set only if we insert record using the object of sent entity. And in case of failed SMS, we are going to store the error message in this field. The thing to remember here is that you cannot put not null constraint on these fields. That is because in case of inbox entry, these two columns will receive null value. Or similarly, in the case of sent, these two will be null. So we cannot put null constraints on these fields. So let's go to VS Code and define the parent class first, and then we will define the entities for each SMS types. Create a file inside entities folder, sms.java. Annotate this class with @entity, @table, name equal to SMS, and then @inheritance, and we need to set an attribute strategy, and here just write inheritance type dot single table. Okay, now here we are going to define all columns which is commonly shared with all child entities, and those columns are ID, from or to, message text, sent or received on, right? Private int ID, private string from or to, private string message text, and private zoned date time, sent or received on. Now let's generate getters and setters, right? Before moving further, I'm going to tell you a feature of Visual Studio Code that you can use to hide the code blocks altogether. For example, in this case, if you want to collapse this, I can only collapse to the scope of this function, right? Now what if I want to collapse all these code altogether? And for that, you can simply write #region, and let's say getters and setters. At the bottom, you can say #endRegion. Now you can fold all the code blocks within this range all together, right? Now let's move back to the topic of this video. This is our ID field, and we want it to be generated automatically. So @ID and @generated value strategy generation type dot identity, right? So save this. Let's create 3 entities: inbox, sent, and failed. Okay, I'm going to create a folder, let's say SMS, and inside this inbox.java. Annotate it with @entity, and here we are going to specify one specific column which is SMS type. Now let's generate getters and setters. Save this. Let's create the another one which is sent.java, entity, private zoned date time, delivered on. Right click, source action, getter setters, save this. Now our last file, which is failed.java, @entity, private string, error message. Okay, save this. Now extend the parent class here, SMS. Do the same with inbox and failed. Okay, save this. Now let's create a repository for all these entities. Inside repository, I'm going to create, let's say, SMS repository.java, interface @repository, extends JPA repository, type of SMS, and integer. Okay, save this. Now let's create one folder here, SMS, and I'm going to create one repository for inbox, repository, extends JPA repository, inbox, and integer. Okay, another one for send interface and integer. Now the last one, failed and integer. Save this. Now let's create a service, and again I'm going to create a single service file to access all these repositories. Okay, so let's say sms service.java. Annotate this class with @service. Now autowire all these repositories. First let's say sms repository, then autowire inbox repository, sent repository, and failed repository. Create a constructor, public sms service. Now let's create a controller and let's define some endpoints there. Inside the controller folder, let's create sms controller.java. Annotate this class with @RESTController. Now @request mapping. Now autowire the service class, sms service. Now let's create our first endpoint. I'm going to create a post request, and let's say add to inbox. Okay, public inbox, add to inbox, and we are going to pass the object of inbox in request body. Okay, now let's return sms service dot add to inbox. This function is not there yet, so let's create it. Save this, and here we are going to simply say return inbox repository dot save. Okay, save this. Now go to controller and let's create few more. Let's say add to sent. Instead of inbox, let's say sent, and this time we are going to pass the object of sent, and return type should be sent as well. Okay, change this to sent, and here as well. Now create this function, and this one is add to failed. Okay, create this function as well. Now go to sms service, and here simply return sent repository dot save. Okay, and here let's say failed repository dot save. Now save this, and as of now we do not have any discriminator column defined in our parent entity class. Okay, so this should automatically create a field dtype in our sms table, right? Now let's run the application. And in console we can see that Hibernate has executed this query, alter table if exists sms add column dtype. So let's check this, right click, refresh, and we can see the column dtype, right? Now let's go to Postman and hit this endpoint add inbox that I have already created, and we are going to submit this record. These 4 columns are common for all these SMS types, and this particular column is unique to the inbox record. Okay, so let's hit send. Okay, we got the status 200. Let's check the console. Hibernate has executed this particular query. Okay, now let's check the data in our table. Okay, the D type is inbox, right? Similarly, let's send this request, add to sent. Okay, now refresh this. This time this field is null and we are getting data in delivered on, and the D type is sent, right? If we hit send here, add to failed, this time these two column is set to null and we are getting error message invalid mobile number. Okay, and the D type is failed. Now let's clear all these records. Okay, and remove this column from here. And now let's add our custom discriminator column, which is SMS folder. Save this. Now go back to Visual Studio Code and open the file sms.java, and here let's specify the discriminator column. Inside this, name and just say SMS folder. Save this, kill the terminal, run the application. Now let's send this request, add to inbox. Status is okay. Now this time we got the identifier in our custom discriminator column, right? Let's try these also, add to sent and add to failed. Okay, now let's see how we can fetch these records. Go to VS Code, go to SMS controller, and let's create few more endpoints. Let's say get mapping this time, inbox, fetch inbox. We are going to pass nothing, and this will return the list of SMS service fetch inbox, and this function is not there, so let's create it. Save this, go to SMS service. Let's say inbox repository dot find all. Okay, let's create one more function here, and this time let's say fetch all. Okay, and this is going to return the list of SMS repository dot find all. Okay, save this. Now go to controller class and create one more endpoint here for fetching all SMS. Let's say all SMS, going to return list of SMS and fetch all. Save this. Now run the application. Let's first hit this endpoint. Okay, copy this URL from here, paste it here. The request type is get, and we are going to hit this endpoint. Send. Okay, we are getting all record. Now let's hit the another endpoint, which is inbox. This time we will get only one record. Okay, and let's check the console. Hibernate has generated this query when we hit the all SMS endpoint, right? And this query is generated when we hit this inbox endpoint. Now let's suppose there are multiple microservices which can access this SMS table, and out of which one of microservice has inserted a new record in this table. But this time in SMS folder field, instead of inbox sent or failed, it has updated this field with the value deleted, right? In such case, when we have a value in discriminator column which we haven't defined in our class hierarchy, it will throw an error. Let's see this. If we hit this endpoint, all SMS, it will throw some exception. Okay, so to handle this, let's create one more entity here inside the SMS folder. Let's create other. Okay, other.java, annotate it with entity, and here discriminator value equal to not null. Okay, let's save this. Now let's create repository for this entity as well. Other repository dot java, interface at repository extends JPA repository other comma integer. Okay, now save this. Now go to our service class, auto wire the other repository as well. Okay, save this. Instead of fetch inbox, let's say fetch others. Okay, going to return the type of other and other repository dot find all. Save this, go to controller, go here, let's say others, fetch others, going to return the list of other. Right, now save this, run the application. We are getting error, and what it is, invocation of init method SMS other. Oh, I forget to extend the SMS class. Now kill the terminal and run it again. Right, now let's hit this endpoint again, and this time we are getting all data. So this is how we use single table inheritance strategy in JPA. This is it for this video. If you like this video, please hit that like button and subscribe to my channel. In next video, we will see the next inheritance strategy in the list. Until then, bye bye and take care.